Hey, what's up? Welcome back. This is day 16 of the Advent of Code. We're going to solve this in Ruby. Today, the problem is called packet decoder, and you receive a transmission and it comes in hexadecimal and a hexadecimal string. So hexadecimal is just another sort of representation of numbers where instead of just having like 0 to 9, you also have A, B, C, D, E, F, and you can encode 16 sort of different numbers inside of hexadecimal. So we typically use decimal, and that's like base 10, hexadecimal is base 16, binary is base 2. And so we're going to receive it in hexadecimal, but then we need to interact with it as if it is binary to decode it. And there's a couple different types of like packets that we're going to receive. So one of the packets is called an operator packet, and then the other packet is called a literal value, or like a literal packet. And as part of the binary representation, we'll have 3 bits that define the version, 3 bits that define the type. And then for literal values, the actual number is going to be encoded in like these 5-bit sequences where the 4 least significant digits in each of those 5-bit sequences is a number, and the first digit in each of those 5-digit sequences tells us whether or not we are at the last digit. So here, because we're on A, we see a 1, so that means that this is not the last digit in the literal value. B has a 1, so this is not the last digit in the literal value. C starts with a 0, so that means this is the last digit in this literal. And so you would kind of add like what is, the digit in place A, B, and C, and that gives you like the ultimate actual number. Or you sort of like combine those 3 into a binary representation which spits out some decimal value. So in this case, 2021. So for operator packets, they're either going to give you like a length type that is 15 bits, and that tells you the total length in bits of all the sub-packets inside the operator packet, or it's going to tell you how many sub-packets there are inside of this operator packet. So you have the literal value, you've got an operator. Inside of an operator, it can either be one that tells you the total length of the sub-packets or one that tells you the number of sub-packets. So then it gets even deeper. And ultimately for this first part of the puzzle, what we want to do is look at each packet, and if it's an operator, we need to like look at all the sub-packets and the sub-packets of those sub-packets, and then figure out just what are all of the versions. So the version again is the first 3 digits of a sub-packet. And so the way that I solve this is sort of by looking at the entire stream of bits that comes in. And then when you're looking at an operator packet, you can sort of tell based on either the length or the number of bits, what sub-packets are coming next. And so we kind of need to like scan through these bits and then break out all of the different sub-packets. So yeah, there's a couple different ways to do this, but the way that I think makes the most sense is by creating sort of a stream of these bits, and then we'll keep reference to where the head is of like our reader. And then we'll kind of like, as we read versions and types and parts of packets, we can sort of like advance that pointer forward as we go through the array. So that's kind of like what I think we'll do. All right, so let's start here. We're going to add day 16 to our solution. We're going to add, decoder.rb. And then we'll add a spec here, day 16 spec.rb. And we are going to require relative. All right, so we're going to say something like it returns the version of the top level packet as expected. Something like that, I think. So if we were to give it just a literal value, I think we want to do something like, decoder is decoder.parse, and then we'll pass it that string, and that will parse out the bits and return a new instance of the decoder. And then we can call like decoder.decode or something, and then we'll expect that decoder.sum versions to equal And this one's version is a 6, version 6 in binary. So we'll say 6. Run this, and we get back nothing because there is no decoder. So let's open up this and define our decoder class. Run our test again, and it should fail because there's no parse method. And this is just going to take in the raw input. So when we receive the input, we need to first break out each character and then convert that to a number in hexadecimal. So I think we can just say like dot map char, and we're going to say like char.2i16.2s2. So this converts it from the letter or number representation into a hexadecimal integer value, and then we're going to convert that integer value back into a string value that represents the bits. And then I think if we say flat map here, we should be able to just get all of the bits like this, I think. I don't know, let's just say like result is this, and then p result, and then run this again. All right, so it did not do what I expected. So it mapped over it, and it gave us all of the individual ones, and then dot join maybe? I don't know, let's see. Okay, so that is sort of the bit string. And then we want to, I guess we actually want dot chars? I don't know, let's see. Does that give us, okay, cool. And then dot map to I, because we want the integer values for all of the numbers. Okay, cool, so that'll give us sort of like the bit string that we want to start with, and I think that matches what we see here. It does. Okay, so that is going to be sort of our like bits or something, and then we want to return a new decoder with those bits. And right now that decoder is wrong number of arguments because we need to accept bits as an argument. Okay, we have no method decode, so let's add that. And we have no method sum versions. So I'm going to just track the sum of all the versions as an instance variable. And then as we go through decode, we will sort of increment the versions. All right, so decode is where we actually need to figure out all of the logic for decoding this sort of stream of bits that came in. So if we look back at this, each bit is labeled indicating its purpose. So the 3 bits labeled V, T, V and T. Okay, so V gives us the version. T gives us the type. So what I want to do is do something like version is like read bits 3, and that'll like just read the first 3 bits in the stream and then advance some pointer. So let's actually say like at red is 0. I don't know if we actually need this, but well, yeah. So read bits n, and this is going to increment read by n. And then what we want to do is we want to return n bits from something, and then we want to update bits. So let's say like our return value is going to be bits.take n, and then we want to update bits to be bits.drop n, and then we'll return ret. And that should give us our version. And we also want to say something like at sum versions plus equals version. And let's just see if this works for our first situation here. Okay, can't, okay, what is this saying? Decoder line 26, the plus method array can't be coerced into an integer. So line 26, which is 26 plus equals version. Oh, right, because we want to convert that into, so this is just going to be the first 3 bits, right? Yeah, so that gives us 1, 1, 0, but we want the value 6. So we need to take those and convert that into we need to map it into a string, or do we? Yeah. Can we just do join? I don't know. Let's see. Okay, and then .2i2. Okay, cool. So this gives us back 3 integers in an array. .join converts it to a string that is 110, and then .2i base 2 gives us the integer value for the version, and that's what we want to increment by. And so now our test is passing. Okay, so that gives us the version for the top level packet, and I think that's okay. All right, so we've got some method that's going to like read some number of bits. Let's also pull out the type ID. So something like type ID is read bits 3.join.2i2, and we'll p type ID. We don't actually care about the type ID for this first part. All that we want is the sum of, we want the sum of the packets. And so I guess what we want to do is sort of like start breaking down these values. So let's make a way to extract the literal value here. And I think that's what we ultimately want to return from decode is some value. So value equals like get literal, and then we'll make a method here, get literal. And what we can do is add another method here that says like it returns the expected literal value for the packet. And then we'll use the same decoder, and we will set the, actually now we're gonna have to expect that the decoder.decode to equal 2021. That's like the year value that's returned. So we need, actually, I guess we can just like return get literal here. So get literal is going to be kind of interesting because we need to sort of like work our way through the bits that are in a literal thing. And this only counts if the type ID is 4. So here we have to do something like if the type ID is 4, then we're going to return get literal. Otherwise, we're going to have to do something with the operator packet. And so this get literal thing, so after we have read the first 6 bits, which we have because we called read bits here and read bits here, some interfaces some interfaces for like string buffers and IO, some other IO objects will like have you read to a certain point, and if you need to rescan, you have to like rewind or reset your reader. So essentially, like after we have read these first 6 bits, now we're ready to start reading the literal value. And the way that we do that is we need to read 5 bits at a time, pull off the first one and check to see if it's a 1 or a 0. So what we're going to do is say something like what do we want to return from here? We're going to return some list of bits. So literal bits is some array or something. And then what we want to do is we want to read 5 bits. So we're going to say read bits 5, and that's going to give us 5 bits back. And I guess like what would be nice is actually if we can like split it into like head and rest, and that will give us, then we can check like if the head is 1, then like keep going, right? Else we've like reached the end and we just want to like end. And what we're doing here is we're using array destructuring to say like pull off the first element and store that in head, and then pull off the rest of the elements and put that in rest or like tail. But we need to kind of like keep doing this until we reach a stopping point. So we actually need to do something like while true, keep doing this. And if the head is 1, keep going. If the head is 0, we need to like, we need to break, right? And I guess we only need to break if head is 0. Break if head is 0. And then Otherwise, what we want to do is say literal bits plus equals rest. And let's just see what that gets us. Okay, we got nil back, so get literal. So if the type ID is 4, and it should be, require by bug, then we have by bug. We should be type ID. Oh, type ID is 6. Is that right? No, the type ID should be, okay. So I think what might be happening is, are we not actually updating bits correctly here? No. Okay, so what I want to do is just keep track of like both bits and like OG bits is bits.dupe. That way we have like both bits and like some other reference of what the original bits were so we can compare. So puts OG bits.join. Okay, puts at bits.join. Okay, so it is shorter, that's for sure. And type ID is 6. Version is also 6. Okay, so I'm surprised because for this example, the type ID should totally be 4. So let's move our by bug higher, and we'll walk our way through it. So p bits.join, p og bits.join. Those should be the same right now. After we read this, we should be done with the first 3 bits. Oh, you know what? Look at this. This is showing 110. This is not showing 100. So something is actually wrong with our decoding. So, or I mean our parsing, I think. So, oh, right, okay. So what's happening is that we're converting it into an integer, and then we're converting it back to the binary representation. But sometimes I think the chars are going to be shorter than 4. Ooh, this is a good chance to use tap. And we can add by bug in here just so that we can see what the current like intermediate representation is of chars. So now we can see like puts C, and we see 1011 next PC. Okay, so see how we only have 10. So at this point, I bet char is, yeah, okay, so char is the number 2. So if we take char.2i16, we should get the number 2. And then we say .2s2, we get 10. But we want this to be 0010 because all of the bits here, we're expecting them to be 4 wide. So what we want to do is we actually want to left pad. So before we get the chars, we're going to call .rjust. So that's going to like pad 4. We want it to have like at least 4 characters. And if there are not enough, then we want to include a 4. So now we can pull out our tap, and it should, I don't know, maybe it'll work this time. Let's see. So after we p at bits.join and p at og bits.join, and then go to the next one, and we have our version, and that's correct. And then we say p at bits.join. It should have 100 at the front, and it does. Okay, so now our type is 4. Type ID is 4, and now we're gonna attempt to get our literal. So let's step into that. And while true, we're gonna like break on line 31, and then we're gonna say something like this. Okay, so literal bits is that, okay. Okay, literal bits dot join or something, I don't know. And then .2i2, cool, 2021, great. So let's add that literal bits dot join dot 2i base 2. Now if we run our test here, this should pass. Great. Okay, so all of our tests are passing. We're able to get literal values out. Let's add another example here where we then have to scan an operator packet. Okay, so we've got that packet. That works. All right, so we have another packet here that is going to be a little different. So we're going to say it, I don't know, what do we actually need out of this? All right, so for these operator packets, we have a new concept. We have this length type ID. So what I think makes the most sense is to just start figuring out what the length types are and make sure that we can do that. I'm not quite sure how to write a test for that yet, so let's just get in here and try to make it work. So I guess if it's not type 4, if it's any other type ID, then we're going to have like a length type, and that's going to be read bits 1. And we only want 1 bit back, and that should give us the right length type. So if length type is 1, we're going to do something. Otherwise, if it's 0, we're going to do something else. So if the case of, if the length ID is 1, then the next 11 bits represent the number of subpackets immediately contained. Next 11 bits is the number of subpackets. Otherwise, if it's 0, this is going to be the next 15 bits are the total length in bits. Next 15 bits is the total length in bits. Okay, so num packets is going to be something like read bits 11 dot join dot 2i2, and then otherwise we're going to have the same thing, but we're going to have 15, and this is like length or something, I don't know. So in our example here, the one that it gives us is length type 0. So let's just see if we get a length type 0 when trying to do this. So it has length type 0. I'm actually just going to call decoder.parse and then .decode, and this just is giving us like a little test harness. And we want to put like, oh gosh, yeah, how do we want to do this? Puts length type 1, length type 0, and then we'll rerun the test and just see what we get printed out. So that is 0, and that is the length type 0. Cool. All right, so then what do we need to do after that? So the 15 bits labeled L, those are all the length of the subpackets, and that is going to give us the number 27 back. And then the 11 bits labeled A are the first packet, and then the 16 bits labeled B is the second packet, and both of those are literal values. All right, so we know the length, and we also know like our read point. And so what we want to figure out is like, we want to continue decoding several more packets until we get all the literal values out of the packets. And so what we need to do here is we want to basically say something like while at read. So like while the point that we're reading at is less than length plus the current position, which I don't know what the current position is going to be. So while read is less than current position, I guess the current position before we start reading is going to be at read. And so while the read point is less than the current position plus however many bits, we want to continue decoding. So we want to call decode, basically, I think. Yeah, I think that's right. And then let's see what we get back. So in this example, we had the version for the first one was 6 and the version for the second one was 2. So that should be 8 plus 1 is 9. So I think some versions here should be 9. Expect decoder.sum versions to equal 9, I think. Current pause. I called it two different things, huh? Okay, so that's working. So at least it's counting up the sums, right? So this is a recursive call here. So we're sort of just like recursively calling and then letting it read as many packets as it can. And while it's reading packets, it's incrementing this version thing. So I think that works fine. All right, cool. So then let's look at a packet that has a length type of 1. So this is going to be a length type of 1. It works for length type 1. And the packet example is this. And what does this consist of? So the first 3 bits are labeled 111. So we have version 7 here. And then we have the length type of 1. And here the value is 3. So that tells us that there are 3 packets, right? Yeah, that's the number of subpackets. So we're going to get 3 packets back, and each of those is a literal. So we have 2 plus 4 plus 1, 7 plus 7 should be 14, I think. So this should, the sum of the versions should be 14. So let's see. Got expected 14, but got 7. Okay, so what we need to like actually implement for length type 1. And did it actually spit out length type 1? It did at the top. Okay, cool. So what we need to do here is we need to say something like numpackets.each do, or like numpackets.times do decode. I don't know. Let's see. All right. Okay. So we have 2 different ways to handle those length types. We're getting the sum of the versions as expected, I think. And then let's see. So after reading 3 complete subpackets, the number of packets. Okay, cool. So here's a few examples of hexadecimal. All right, so here's the example. So this one should have a version sum of 16. So we're going to say it works for example blah. Oh, in fact, there's a really cool feature of our spec that, or there's like a handy approach to writing specs where you can like generate several. So what I'm going to do is I'm actually going to iterate over these pairs of like input and what we expect. So let me show you. First, we can write it manually. So we'll have like these ones, right? And what we could do is say like, okay, here's the input. And we expect this to have like a version sum of 16, right? And what we can do now is say, okay, because we want to test all of these different pairs, we can create an array of arrays where the first element is this string, and the second element is the value we expect, so 16. And then we can just iterate over that array of arrays. And inside of each block, we're going to have something like the packet and its length, or like versions. Like, yeah, this should be like some versions. And then here we can just pass in packet. And inside of our it block, we can, pass in the packet so that we can see each it statement, or like the test description will print out the different value for each possible sort of packet here. All right, so we will add one of each of these. All right, so we've got 16, the next one is 12, the next one is 23, and the next one is 31. And then we just cross our fingers and wow. Okay, it works. They all pass. So I think we're at a good point where we can jump into the decoder and pass in our input. So get our puzzle input here, this huge giant thing, and we'll just say like puts, or like decoder is decoder.parse giant string decoder.decode puts decoder.sum versions Ruby day 16 decoder, and we get 963. 963 was our answer. Okay, super cool. So that is like how we're decoding the packets and summing up the versions, and that is part 1 for day 16 of the Advent of Code. Let's get into part 2. So now that we've got the structure of all the stuff that's being transcribed, now what we need to do is look at the type ID more carefully. So the type IDs are going to map to some operation that we want to apply to all of the values of their subpackets. Okay, so before what we were doing is we were looking at the type ID, and if it was 4, we know it's a literal value. If it's anything else, we were just like summing up the versions. What we need to do now is figure out like, oh, if the type ID is 0, then we need to take the sum of the packets. If the type ID is 1, we need to multiply the values of all the packets. If the type ID is 2, we need to find the minimum value. If it's 3, the maximum. If it's 5, greater than, etc., etc., etc. So to do this, we first need to figure out like how to keep track of all of the actual values. So in the case of type ID 4, we're just returning the literal value. In any other case, what we need to do is actually like collect up the results of decoding those other subpackets where we reach a literal value at the end, and then we need to figure out what the type ID was at the operation level and apply that. And so inside of the else block here, when it's not type 4, what I want to do, in fact, like let's just say like return get literal if type ID is 4. That'll be like an early return, and we can unindent a little bit here just to like clean stuff up just a hair. All right, so then if we are not in the case of a type 4, what we want to do is keep track of literals, and we're going to store those in an array. And if we're going through type 1, we want to just collect up all the literals and we'll decode those. And if we're going through type 0, we will also just collect those up into literals and decode. Now, after we finish either of these two blocks where we're recursively calling decode, this is where we need to say something like if type ID is 0, then we need to return something like the sum of the packets. So now we need to say like literals.sum or something like that, right? And so here, this is going to give us a couple of different examples of what value we should expect back. So let's go back to our test, day 16 spec, and we'll say something like it works for type. Okay, actually, let's do something similar with this sort of like generated it block. So we're going to pass in, again, we're going to pass in some values or some like packets, and then the resulting value that we expect from the packet. So it calculates the expected value for the packet given the operations. Again, we're going to have these three sort of things, and then actually this is just going to be decoder.decode, and this is going to be sort of the value. All right, and then what we're going to do is we're going to start with this packet here. And it says that it finds the sum of 1 and 2 resulting in the value 3. All right, so we can run it with just that one case. And I've spelt something wrong, and that's okay. And let's see. And let's also just put in the packet ID here so that we can see it. Literals. I spelled something literals wrong here. Literals. Run the code and we crashed. Nil cannot be coerced into an integer. So where are we at? Oh, this needs to be commented out. And then we can run it again. All right, let's just make sure that works. Okay, so that is going to work for sum. So then we can say like else if type ID is 1, literals dot product. Is product a method on array? Let's see. So if we have a is 1, 2, 3, 4, a dot product. No, that's interesting. I don't know if I've ever seen that one. So, okay. Maybe it's like sort of like cross product of two arrays or something, or like empty array. I don't know. So a dot prod. Okay, maybe there's no method for it on array. It's okay. So let's just do a dot inject, and we'll pass in the symbol for multiplication, and that'll give us back what we want. All right. So we're going to just say inject the symbol for multiplication. And actually, we should have had a failing test first, whatever. Not a huge deal, you know what I'm saying? There's this guy on TikTok, Food with Cooge or something like that. So funny. I am a huge fan. He just talks about like a bunch of his meals and his food, and he's got this like super thick New York accent. And yeah, it's good times. Really fun TikTok material. Are you a huge TikTokers? Do you watch TikTok? Do you watch Dev Talk? Let me know down in the comments below. Yeah, super curious to hear if that's something that you do. Okay, finds the minimum. All right, finds the minimum. So min is a thing, right? So else if type ID is, this is probably 3 maybe. Oh no, 2. Okay, so what I'm thinking is, okay, there's a really interesting property of inject where you can pass it, like inject is a really, inject and the concept of reduce is a really flexible concept. And as I'm looking at this, I'm seeing like, okay, literals.sum could actually be implemented as part of inject, right? And you can pass in, we can pass in the plus sign, and that would give us the same result. Also, minimum technically could be, minimum could be implemented as inject also, right? So you would just say something like, you can just, no, yeah, you would need a or like min, and so maybe you start it, actually, yeah, whatever. You need min and you need current, and if min is less than current, then you return min. Otherwise, you return current. That's like another way to implement inject. Cur and cur. Cur is too many. There's too many here. Okay, so what I'm thinking is we actually could implement all of this as a map of integer to symbol, or integer to like block. So let's do that. So we're gonna have some like operations here. So we're gonna call it like ops is something where we have 0, 1, 2, 3, 4 points at nil, because remember type 4 is for literal values, 5, 6, and 7. So these are all the different types that we can support. 0 is going to be plus, 1 is multiplication, 2, I think we need to pass in like, yeah, the accumulator, so min and current, and this is going to be like min is less than current, then min else current, and let's see, the next one is max. So it's going to be kind of the same, but this will be max. And then we want to like reverse the direction there. And then actually, yeah, that's interesting. So what can we do? Like A is 1, 2, 3, 4, and then A dot inject colon max? No. Colon ampersand max. No, yeah, because that's going to be calling max on each integer. Doesn't make sense. Okay, so then what is 5? Produces 1 because 5 is less than 15. Okay, so 5, packets with ID 5 are greater than packets. Their value is 1 if the value in the first subpacket is greater than the value in the second subpacket. So this is actually like pretty close to this. But you actually just have like A and B. And if A is less than B, then you return 1. Otherwise, you return 0, something like that. And I think 6 is going to be the opposite. And then 7 is equal to. Okay. So then 7 is, if they're equal, then you return 1. Otherwise, you return 0, something like that. All right, so let's just round out our examples here. And crashed and burned. Okay, oh, right. Okay, so when you're making a dictionary with key values or keys that are integers, then you need to like, we have to use the hash rocket syntax. Otherwise, it turns them into string symbols or something, I think, maybe. Maybe I'm wrong. Did I miss a comma? Oh, yeah, I'm missing commas. Does that other way work? As long as I've got these commas in the right spots? Yeah, I didn't think so. Okay. Expected 1 got nil. Okay, so then for our actual implementation down here, we need to update it so that we're saying something like literals.inject, and then we want to pass in ops at type ID, right? And because some of these are procs, and so like inject allows you to pass in just a symbol. That's a shortcut though for turning it into a block. And so if we put an ampersand in front of it, then it will blockify the symbol and apply it as we expect. And because some of these are also lambdas, so this is a lambda expression if you haven't seen this in Ruby before, head over and check out the video I have about blocks, procs, and lambdas, but we're passing lambdas, but we want to convert them into blocks before they execute. So we want to pass this little pretzel thing, the ampersand, right in front before we run it so that it blockifies it. Okay, so let's see, given it did not work for this one. Produces 1 because 5 is less than 15. Oh, it should have been 1. Okay. So that one should have been 1. And then the next one is 0 and 0. Okay. So this is 0 and 0. Let me see if that works. I misread the example there. Okay. Produces 1. Expected 1 but got 0. Okay. So, because 5 is less than 15. All right, so let's p literals here and see what we get. So this was our failing test. One thing about this is it makes it a little bit harder to like narrow it down. So one thing you can do is just kind of like comment out some of the cases to like really get the scope right. So literals, I don't know why that's so hard to spell. So ops at type ID is a proc. Okay, that's really hard to read. Okay, decoder line 10, whatever is on that line. I don't know if we can like cat that out. I don't know. Let's see. Cat this thing. Oh, we can also pipe it to less. And then look at like 1, 2. Oh, actually, let's also look at type ID. So type ID is 6. So it should be this one here. And if type ID is 6, then less than. It should be less than. Oh, okay, I got 5 and 6 messed up. Got 5 and 6 messed up. So I think it's, I just got them opposite. So this should be, I think this is like, this is greater than, this is less than or something. Yeah. All right, so let's run it again. Okay, all examples are passing. Let's comment all these back in. And we've got 16 passing tests, and I think we might actually have like a solution here. So in this case, we want to see what do you get if you evaluate the expression represented by your input. So after we decode, we actually just want to like put what we decoded. So let's run this thing. We get this giant number, 1549, blah, 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 and that was the puzzle answer. Very cool. So that is how you solve day 16 of the advent of code. This is kind of cool and kind of neat. I don't know, having a dictionary. I guess we could have also just made this an array, right? Where we index into the array. That probably makes it a lot simpler and cleaner since we have integer indices. And it should work exactly the same, I think. Yeah, it works exactly the same. So let's also do some more cleanup here. This was kind of messy, but gosh, like always dealing with the incoming formats is always just like kind of a mess of 2 I's and 2 S's and splits and chomps and maps and whatever. So not sure how to improve that very much. We've got our get literal stuff. That all looks pretty good. We're sort of like splitting and incrementing. That's cool. So what else do we want to do to clean this up? Gosh, you know what? The other thing is that I guess we could make a method that converts bits back into integer values. Are we always doing that every time we read bits? Every time we read bits. Okay, so here we... yeah, so here we don't want it. Here we do, here we do. Here it wouldn't matter. Here we do. Here we do. Okay, so what I'm thinking is we can make another helper here that is like, maybe we just call this one like underscore read bits, and that's like the private version. And then read bits actually just calls underscore read bits of n and then calls join.toI2. And then we can just update this one get literal method to use the private one, private or underscore, I don't know. And then this is failing now because we can actually go and remove join.toI from all of these places. And I think this one we want to keep too. Anyways, all right, let's run it again. And our tests are passing. So that kind of cleaned it up just a hair. But otherwise, yeah, I think I'm pretty happy with it. This method is too long. This decode method is way too long, but it's fine. It's whatever. And we'll live with it. So cool. Thanks so much for watching, and we'll see you in the next one.